Hello, good afternoon.
Good afternoon, sir. Welcome to the FTP,
Good
sir.
afternoon, madam, everyone. I am Prakash,
Sir, we will start the
resource
program, sir.
person of today's session. Yeah,
Okay, sir. We will start the program, sir.
yeah, we'll start the program, madam.
Okay, sir. Thank you, sir. So, good afternoon, distinguished guests, faculty members, and participants from various institutions. Education is our passport to the future. For tomorrow belongs only to the people who prepare for it today. With the quote of Malcolm, I welcome you all for the fourth day of National Level Virtual Faculty Development Program on Data Driven Insights on Applications of Mathematical and Statistical Modeling, organized by Department of Mathematics in association with IQAC, St. Joseph College, Chennai. A day without prayer is a day without blessing, and a life without prayer is a life without power. With the beautiful lines, I would like to call upon Mrs. Flora Evangel, one of the coordinator for this FDP, to lead us into the prayer.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Dear Lord, thank you for the goodness and mercy that we receive every day. Loving God, as we begin this session, we ask for your guidance and wisdom to work together in harmony. Bless our founder, Reverend Father Dr. J.E. Arulraj, enthusiastic administrator, Reverend Sister M. Baby, dynamic principal Dr. R. Ruben, and our today's speaker Dr.V.Prakash, principal of Dr.Ambedkar Government Arts College, and all the participants from various institutions for this FDP. Bless our resource person to share the most of his knowledge in the field of expertise, and may we also observe the invaluable knowledge experiences put into practice, what we may learn today. We ask this prayer in the name of Jesus Christ our Lord. Amen.
Thank you, ma'am, for your soulful prayer. To formally start the program, may I call on Mrs. K. Sujata, Head Department of Mathematics, for the welcome remark. And I request also introduce the resource person for this day.
A very good afternoon, one and all present here. With the blessings of God, the Almighty, and the wishes of our founder chairman, Reverend Father Dr. J. Arul Raj, I welcome you all for the 5 days national level virtual FDP on data driven insights on applications of mathematical and statistical modeling. The main aim of conducting this FDP is to get leadership qualities, pedagogical expertises, and individual development. On behalf of our management and the Department of Mathematics, it's my great pleasure to welcome and introduce our today's resource person, Dr. V. Prakash Sir, Principal, Dr. Ambedkar Government College, Chennai, who will be presenting in the title Efficiency Measurement EDA Approach. Sir is a distinguished academician, and he is renowned for his exceptional contributions to the field of education. Despite of demanding schedule, his commitment to fostering academic excellence is evident in his noteworthy achievements and leadership roles. Sir has guided 16 MPhil students and 9 PhD scholars, showcasing his dedication to nurturing scholarly pursuits. With an impressive publication record of 26 works, his research has significantly entitled the academic landscape. Notably, Sar serves as the chairperson for the Plus 2 Business Maths and Statistics book published by the Tamil Nadu Textbook Society, illustrating his influence in shaping educational resources. His impact extends beyond the college as he holds the position of chairman and board of studies in Madras and other universities in Tamil Nadu. Additionally, SAR is actively engaged as a member of various academic bodies, further solidifying his commitment to advancing education in this session. Thank you, sir, for accepting our invite. Welcome you, sir. I wholeheartedly welcome our beloved administrator, Reverend Sister M. Baby, and our eminent principal, Dr. R. Ruben sir for their guidance and support to conduct this FDP. Welcome, sister. Welcome, sir. I extend my warm welcome to all the faculty fraternities from our college and other various colleges. We hope all the participants will be benefited and get substantial improvement in the education context through this FDP. Once again, I welcome you all.
Thank you, ma'am, for your warm welcome. Now, I request Dr. V.Prakash, the speaker of the day, to take over the session.
Good afternoon, everyone to present here. First of all, I would like to thank management and HOD of mathematics and faculty members and provided me this great opportunity to speak before you, my dear participants. Today, my subject of the talk is efficiency measurement of the organizations. That means similar type of organizations. There are many methods for efficiency measurement, and probabilistic approach and deterministic approach. That means parametric and non-parametric. And as far as the parametric approach is concerned, there is a method called stochastic process. That means stochastic modeling. And now I am going to talk about only the non-parametric method, which is popularly known as the data envelopment analysis. Let me share the screen now. So this is my topic today, efficiency measurement, that to DEA approach. And in production theory, there are two terms popularly known as productivity and efficiency, and both will discuss. So the performance measures, that means performance or efficiency measures. As I said, there are many methods. The most common measure of performance is the productivity ratio, that is the ratio of output to input. And this is a familiar one, but there is some problem in measuring the performance efficiency as far as the production unit is concerned. There are some methods of performance measurement, and this can be applied to private. So whatever it may be, the efficiency measurement or productivity of units, measuring their efficiency is very important nowadays in the competitive world. Each one wanted to know what is the efficiency factor involving in productivity. So all are producing some goods. Many similar type of organizations producing a similar type of outputs, but their production efficiency may be differ from one unit to another unit, and also they claim each one they are efficient by measuring their own scale. So to avoid that, there is a common method to measure the efficiency of similar type of organizations. So that is a famous method called DEA. So first, let us see what are the performance measures available in the literature of productivity, I mean production theory. So the principal method for efficiency measurement are, the least square econometric production models and total factor productivity index and data envelopment analysis and stochastic data. And that means there is pure related to statistics. And coming to the stochastic frontier, SFA, that is also used to measure the efficiency or performance of production units, but it is a parametric approach. Some complexity is there by using that method. The major drawback in applying stochastic frontier is it can be used to measure the efficiency by using one output with a multiple set of inputs. When there are more than one output comes, the situation becomes complex. Then the fourth one is that means the data envelopment analysis is the most popularly method of measuring efficiency for the past 4 decades. Please, participants, kindly let me know whether I am audible. Am I audible?
Sir, you are audible, sir.
Thank you very much. Thank you. Okay. Can I proceed, madam?
You can proceed, sir. Yes, sir.
Okay. Screen is visible. Screen is
Yes,
visible
sir.
because I didn't get any response from your side. That's what I'm saying. Okay.
Yes, sir.
Okay. Thank
Your
you.
screen
Thank
is
you.
visible,
If
sir.
everything goes well, very good, madam.
Yes, sir. Yes, sir.
Okay.
Yes,
Thank
sir.
you very much.
Thank you, sir. Thank you, sir.
Okay. Next. So a major rationale began measuring productivity and efficiency that there are most common parameters to describe the relative performance of the production units. So the concept of productivity, productive efficiency, and its rigorous mathematical measurement was propounded. The first it was propounded by Koopmans and Debreu. So both Koopmans and Debreu in 1951 they only obtained the measure of productivity efficiency. So in the production theory, major pioneering contribution is made by that means Koopmans and Debreu. So the concept of productivity and efficiency, this is a very important point. As such, it seems the productivity and efficiency are synonyms, but it is not so. The production theory, productivity is nothing but the ratio of output to input. But the efficiency of the production unit refers to the comparison between the observed output to the potential output. So both are, this is a major difference between the productivity and the efficiency. So the efficiency of a production unit can be technical efficiency and allocative efficiency. The next one is scale or economic efficiency. So technical efficiency is nothing but the minimum inputs used to observe maximum outputs. By a particular unit taking minimum of inputs and producing more outputs. So it's that unit efficiency is measured by what is the maximum output that particular unit gives by taking the minimum outputs. That is called a technical efficiency. So the basic concept of efficiency is this one. That means what is the output per unit of input? A particular unit, what the output of the particular unit with the per unit of inputs. So the concept measurement of efficiency is defined only in those days, like output, the ratio of output to input. But this creates some problem when there are more than one input and more than one output. It is very simply ratio of output, input and outputs situation arises, the problem becomes very complex. Then only we think of applying the data envelopment analysis, which has been used for more than 4 decades. Okay. So these are the efficiencies, scale efficiency and as I said, technical efficiency is minimum inputs used to observe maximum outputs. The scale efficiency is nothing but the aggregative efficiency by technical efficiency. That means a unit is said to be scale efficient when its size of operation is optimal. Size of operation is optimal. So when you increase the number of operations or decrease the number of operations, definitely it affects the efficiency concept. So the last one is allocative efficiency. It is nothing but the ratio of cost efficiency divided by technical efficiency. As I said, technical efficiency is nothing but output per unit of input. Similarly, the cost efficiency is that is also the ratio price of input and price of output. That gives you the concept of, that means the definition of cost efficiency. So the ratio of two, the cost efficiency and technical efficiency, gives you the allocative efficiency. Here I clearly mentioned the scale efficiency is aggregate efficiency. That means average efficiency by technical efficiency. Allocative efficiency is cost efficiency by technical efficiency. And cost efficiency is price of input divided by price of output. And technical efficiency is output per unit of input. So allocative efficiency you can define in this way by substituting what is the cost efficiency and technical efficiency. So as I said, the Koopman and Debreu and Farrell, all they contributed in the efficiency measurement in different way. For example, the Koopman's 1951 defined the technical efficiency of input on the basis of disposability conditions. That means the vector of input is technically efficient if and only if increasing any output or decreasing any input is possible only by decreasing some of other output or increasing some other inputs. This is the definition of technical efficiency in absolute term defined by Koopmans in 1951. Now, next, 1951, the next one is Farrell in 1957. He presented a measurement of technical efficiency in relative term that differentiate efficient unit from other production unit. Initially, the Farrell in 1957 presented a paper relating to the measurement of technical efficiency by using the single input and single output. When the more number of inputs and more number of output, that means in case of the multiple input and multiple input or output situation comes, then he could not think about it, so he left it as such. Okay. Then similarly, Debreu also gave a measure of technical efficiency in terms of maximum possible proportionate reduction of all variable inputs or maximum possible proportionate expansion of all output, which is called as a radial measure. So Debreu defined a radial measure to measure the technical efficiency. In econometric modeling, all these three, so the major three, Koopmans and Debreu, Farrell, they contributed more in econometric modeling, these three approaches. And even now, the three approaches are considered by the researchers for studying the economic efficiency, which is known as the cost efficiency and the technical efficiency measures. So this is the Farrell measure of efficiency. In Farrell in 1957 has made a pioneering, actually he only made a pioneering contribution. He contributed more to the concept of the measurement of productivity efficiency based on linear programming model. This idea has led to the development of two major areas of research. One is stochastic frontier approach and the data envelopment analysis. As I told, this data envelopment analysis is non-parametric approach, whereas in stochastic frontier involves some parameters. So there, the estimation of parameters is very important in stochastic frontier. That too, it's applicable. It is like a regression analysis. In regression analysis, what we do, we have one variable y is equal to alpha plus beta 1 into x1. So with a lot of variables x1, x2, xn. Y depending on x1, x2, xn, and all these x1, x2, xn are independent variables, and y is a dependent variable. It is similar to regression analysis. The next one is, it is also the stochastic frontier approach is also not getting very popular because it involves the parametric estimation at a certain stage. Nobody can use of it. Therefore, the very easy and the most popular one is data envelopment analysis, which is a non-parametric approach. It is purely based on optimization technique. Hope that you know all what is meant by optimization technique. That means maximum or minimum. Okay. So a different type of non-parametric estimation is the data envelopment analysis. So basically, the data envelopment analysis is a model, mathematical model based on linear programming problem. It measures the efficiency of similar type of organizations called as decision-making units, and data envelopment analysis has emerged as an important tool in the field of efficiency measurement. So, out of many efficiency measurements, this DA getting more popular because of its flexibility. If the data set is available only for the quantity of input and output, technical efficiency can be. These are the features of DEA. So you have a set data set which consists of quantity of inputs and output. The quantity may be anything. One may be in numbers, the other may be in dollars. So the different unit of measurements, all the inputs have. Similarly, each output is measured in different unit measurement. Even then, the technical efficiency can be calculated with the DEA. So when the price data is available, we can calculate, instead of technical efficiency, we can calculate cost efficiency. Okay. During the period of 83 to 85, the methodology of DEA has been applied. Actually, initially, first after the Farrell contribution in the efficiency measurement or productivity measurement, in 1978, Charnes and Cooper and Rhodes, CZR model, they only developed DEA, data envelopment analysis. Because as I said already, the Farrell's measure of efficiency is used only for the single output with the multiple inputs. When the multiple output situation comes, when multiple inputs and multiple output situation arises, then the Farrell model, that means Farrell's efficiency measure, is not a suitable one. So after 20 years, there was a huge high break. No method is available to measure the efficiency of production units. Then only in 1978, the Charnes Cooper Rhodes, they contributed to the field of efficiency measurement. They developed a model that is called as a basic model of DEA, data envelopment analysis, which is the powerful efficiency measurement tool. It was developed by Charnes and Cooper Rhodes. It deals with multiple inputs and multiple output situation, and it gives the efficiency measures. So, as I said, data analysis, DEA, is a linear programming methodology to measure efficiency of multiple decision-making units when the production process presents a structure of multiple inputs and multiple outputs. Okay, for example, there are many examples of similar type of organization decision-making units. For example, if you take a bank efficiency, banks have the similar structure of multiple inputs and multiple outputs. Let us discuss one by one. So this is the basic concept of DEA. It's based on, it's a mathematical modeling technique based on linear programming problem, which is used to measure the efficiency of decision-making units when each decision-making unit is presented with the multiple inputs and multiple outputs. It is developed in the year of 1978. So since 1978 until now, there were a huge number of papers published in DEA literature. You can find the DEA is based on the three principles. One is the efficiency measurement, and then input and output orientation. Then the next one is non-Archimedean property. Efficiency measurement, it is used to measure the efficiency of decision-making units. And as far as the orientation is concerned, there are two types of orientation. One is input orientation. The next one is output orientation. Input orientation means minimize the inputs and gives the maximum output. And output orientation is maximum output with a given level of inputs. This is the basic difference between input and output orientation. The orientation, choosing of orientation is depending upon the application of DEA in the respective field. And then non-Archimedean property, actually they fix xi, the input and output, is greater than or equal to 0. Then they found if suppose if one of the input is 0 or output is 0, the ratio becomes 0. So to avoid it, they used a non-Archimedean property, which is known as the epsilon, which is equal to 10 raised to the power of minus 12. So features of DA, increasingly popular management tool and commonly used to evaluate the efficiency of number of producers. Producer here you mean the decision-making units. It's an extreme point method and it compares each producer with only the best producer. So among the producer, we identify the best producer first, then we'll compare the other one. Each one has to compare with the best producer and find the sources of improving the efficiency. So DA is not only used to measure the efficiency, it gives the sources of improving the efficiency for the inefficient units. So producer is usually referred to as a decision-making unit, and DA has been used for both production and the cost data. So building the ideas of Farrell, as I told, okay. So basically your DA is builded, that means developed on the ideas by Farrell, and you can find its seminal work is measuring the efficiency of decision-making units by Charles Cooper Rhodes in 1978. So this Charles and Cooper and Rhodes in 1978, they proposed this model or developed the model based on the ideas obtained by Farrell in 1957. It is based on the linear programming problem. It is estimate empirical production technology frontier for the first time. The main developments of DA in the 1970s and 1980s are documented by, and you can find the Seaford and Troll. They documented what are the developments that took place in the field of DA literature between 19 and 70, and Seaford and Troll was prepared the bibliography which indicates all the developments, main developments took place between the year of 1970 and 1980. So applications of DEA. So here you see industry, banking and finance, educational program, and hospital management. Or similarly, wherever it is possible, you can apply DEA to find the efficiency. Even in that means in educational program, industry means any type of industry. But only thing is they should have a common inputs and common outputs. You cannot compare the efficiency of industry with the bank, or you cannot compare the efficiency of bank with the schools like that. So the decision-making units are similar type of organizations. It should be. The advantages of DEA. No need to explicitly specify a mathematical form. This has no mathematical form. As I told, it is only based on the optimization technique. Maximize or minimize. For example, maximize your profit and minimize your loss, and minimize your production cost. Thereby, you can maximize your profits. Okay. Capable of handling multiple inputs and multiple outputs. Capable of being used with any input and output measurement. It is free from the unit measurement. The sources of inefficiency can be analyzed and quantified for every evaluated unit. Okay. The disadvantages of DEA. Results are very sensitive to the selection of inputs and outputs. Okay, you cannot test for the best specification, and also the major disadvantage of DEA is there is no common rule, hard and fast rule for the selection of inputs and outputs. So how to select the input and output for efficiency measurement? It depends upon the expertise suggestions, or by experience you can select. Otherwise, there is no rule for selecting the inputs and outputs. Only by judging the situation you can choose. These are all the inputs and these are all the outputs. Okay, as such, in the DEA literature, there is no common rule for the selection of inputs and outputs. But only thing is to make a proper bifurcation between the efficient units and inefficient units. there is a thumb rule. That means the number of inputs and outputs should be at least, that means the number of decision-making units should be at least equal to 2 times of the sum of the inputs and outputs. For example, the number of inputs is 3 and number of outputs is 2, so 5. So your number of decision-making units should be at least equal to 10. That means 2 times of the number of DMUs is equal to 2 times of the sum of the inputs and sum of the outputs. That is also only the thumb rule. Okay. So this is the schematic diagram which explains you the DE literature. The pictorial representation given by Seaford in 1994. As I said, piecewise linear, and there are 2 methods. One is CRS and another one is VRS. CRS means constant returns to scale. VRS means VRS, variable returns to scale. And in both VRS and CRS, there are 2 oriented. One is input oriented and output oriented. There is another oriented, non-oriented is also here. Okay, CCR input, everything. So in both the cases, and your CCR method is known as CRS. CCR admits only CRS, constant return to scale, and BCC admits only variable return to scale assumption. Am I clear, madam? Sir, am I clear?
Yes, sir.
Oh,
Yes.
right. So discussion we will have in the later stage. Am I correct? Let me finish the presentation and please come forward for discussion after my presentation. Okay? Thank you. So these are the decision-making units. So decision-making units are nothing but similar type of organization which consumes identical inputs and produce identical outputs. It includes manufacturing units, departments of big organizations, and such as, you see, these are the decision-making units. As far as the university is concerned, you consider 5 or 6 universities. They have the common inputs. What are the inputs of universities? And the teaching, library, books, infrastructure. These are all the inputs of any university. And as far as the output is concerned, what is the project they got, and what is the that means a PhD produced, how many MPhil produced, and what is the result of each course, and these are all the outputs. What are the, so as I said, if you consider the universities as decision-making units, you can easily view that each university consumes identical inputs and produce identical outputs. And similarly, schools, bank branches, and hospital power plants. So these are the examples for decision-making units. All these are similar type of organization which consumes identical inputs and produce identical outputs. So as I said, this is the Chorner and Cooper Rhodes in 1978. They developed this model. It is popularly known as CCR model, Chorner-Cooper Rhodes model, which admits constant return to scale assumption. So first DEA was developed based on the constant return to scale. So in the initial years, DEA was not getting so popular because of this rigid assumption. Most of the economists feels that it is a very rigid assumption. So the DEA was not getting so popular in those days. So the next model developed by BCC, Banker Charles Cooper, that we will see later on. Okay, so CCR, here also the CCR Charles Cooper Rhodes method has 2 orientation. One is input orientation and output orientation. And the CCR model is developed based on the linear programming problem, which is a familiar concept in operational research. So, since CCR depends on that means admits only the constant return to scale assumption, and the next one is Banker and Charles Cooper et al., that means BCC model. They extended the CCR model just by admitting the convexity constraint. That convexity constraint admits variable return to scale And from 1984, the application of DEA becomes very wide. In almost all the fields, everyone started using this the DEA because of its specific characteristics, which admits variable return to scale. Because the constant return to scale is a rigid assumption. We cannot always expect the constant returns for our investment. The returns may be either decreasing or increasing or the same one. So this Banker and Chalmers-Cooper developed the model. That means extended the CCR by including only one convexity constraint. And when we look at the model is generally termed as BCC DEA model, and it allows, as I said, variable return to scale means it may be increasing returns or constant returns or decreasing returns. Since 1984, data envelopment analysis has had more popular and worldwide attention. It has been applied to almost all fields of business, management, science and technology, etc. So these are the two models, Chalmers, Cooper, Rhodes, and Banker, Chalmers, Cooper, BCC model. Then we'll see the mathematical. That means for each input and output, we'll attach a weight. The main problem is to find, to assign the common weights for the inputs and outputs for all the DMUs, so that the efficiency will be meaningful. Otherwise, one DMU will give more weightage to one of its input or output. The other DMU is not so. So when you compare the DMUs, the efficiency of DMUs, the efficiency will not be meaningful. So the main objective of DA is to assigning the common weights to each DMU. That means all the DMUs. Then they will calculate efficiency based on that. So this first they developed only the fractional programming problem. Here we have a set of inputs Xij's and outputs YIR. Okay, so if we have to assign that U1, U2, UR, so we'll attach some weights for the inputs and outputs. When you run the program, maximum of H0, that means the ratio of output to the input, and subject to this condition, it gives when you run this model, when you try to solve the model, this model obtains U1, the weights of the outputs and weights of the inputs, weights of the input and weights of the outputs. But this fractional programming problem is not easy to solve. It gives infinite number of solutions. So they started thinking what to do. Then the same Chalmers and Cooper Rhodes converted this fractional programming problem into a linear programming problem by making the that means the denominator as 1 equal to 1. That means normalizing the denominator. This fractional programming problem is converted into a linear programming problem. Okay. You see, maximum of what they did. So simply they normalizing the input. That means the denominator. Some of the product of weights and the inputs equal to 1. So the maximizing the sum of the product of outputs and its weights subject to this condition. When you solve this problem by using any software, basically Taha, it gives the weights of inputs VIs and weights of outputs VOR. So by having this weight, it gives the one more thing W0, which is the efficiency of a particular DMU, observed DMU, which is under the evaluation. This is known as output maximization model. Output maximization model. You see in the objective function, maximum of W0, mu comma V. Those are the parameters. Okay. So when you run this program, it gives the value of W0, objective function value, which indicates the efficiency of a particular DMU, which is under evaluation. And also it gives the weights of input and output of the observed DMU and all other DMU. So you see this mu r is greater than or equal to epsilon, and V is that greater than or equal to epsilon. first it was introduced only 0. Suppose if all weights, sum of the weights become 0, the product will become 0. Therefore, to avoid that, they used non-Archimedean constant known as epsilon. Mu r and VA is greater than or equal to epsilon. That epsilon is nothing but 10 to the 10 raised to the power minus 12. That means it should be at least equal to some 0.0001. It should not be equal to 0. This is known as the CCR output maximization model. The first one, the CCR output maximization model, is known as the multiplier version. So we all know the concept of linear programming. We all know, we should know, every primal problem has its dual. Every primal problem has its dual. So similarly, the maximum output oriented model is has its dual called the input oriented CCR model. Here, minimization of theta subject to this condition, y lambda, you know, y is the output, and x lambda, which when you run this program by using the same Torah package or any other package which is available in the market, that gives you the value of, that means minimum value of theta and value of lambda. Lambda is the weights of inputs and outputs. This is called as a envelopment version. The first one is multiplier version. The next one is envelopment version. So a particular applicant emphasize more on weights and weights of that means inputs and outputs. There they can use only the multiplier version, and some of the decision maker will more emphasize on decision making units. There they can use this input oriented model. That means the envelopment version. So the version what we decide to use depends upon the our decision. That means what we are going to emphasize. Okay. So lambda is a weight of a DMU, and where theta is a scalar, it gives the efficiency measurement of a particular DMU, and this theta lies between 0 to 1. When theta value is equal to 1, that particular DMU which is under evaluation is efficient, otherwise it is inefficient. For example, theta is equal to 1, we can say that particular DMU is 100% efficient. Suppose theta is 0.98, which is less than 1, we can say it is 98% efficient. Efficient in the sense means what? Efficiently, the particular unit converting all its inputs to outputs. If you say a particular DMU obtains a value of 0.98, it converts only 98% of its inputs to outputs. So 2% that particular DMU has been wasting. Therefore, it is inefficient. So similarly, the first I said the fact in discussing the fractional programming problem, it is the maximum of H0, the ratio of output to input. There I normalize the input, that means the denominator. That problem becomes output, that means input oriented. Now, when you normalize the numerator, the fractional programming problem can be converted into a linear programming problem. It is known as output oriented CCR model. You see summation of mu r into y r not equals 1. Okay. So here also for the same output oriented CCR model has its own dual known as input minimization CCR model. Okay, here also W naught star and everything. And that subscript I indicates the input. The second subscript indicates the DMU. O means observed DMU. So output oriented CCR model is maximum of 5. That means the dual version of input oriented becomes the output oriented CCR model, maximum of 5 subject to this condition x lambda and all that. Here there is a theta, minimization of theta inputs. Here maximum input of minimization input means decreasing of inputs, proper reduction of inputs and produce more outputs. Here augmentation of outputs with the given level of inputs. The particular DMU which maximizes its output with the given level of input is said to be efficient. Okay. So here you see, we consider this example, one input and one output. One input and one output example. I consider the 4 DMUs. 4 DMUs, you see, it is given sales and workers, and here we have only one input. What is your input? Workers is the input, and one output, which is sales. Am I correct? So to find the efficiency, it is simple. By the basic concept of efficiency, it is a ratio of output to input. That is y by x. Am I correct? Y by x. So the relative efficiency is given to you. Okay. 0.5952. The most important advantage of DA is that it can be handled multiple input and multiple output variables, which are generally not comparable to each other. So these are the relative efficiency. As far as the first DME is concerned, it is 59% efficient. DME 2 is concerned, it is 79%, all that. DME 4 is absolutely efficiency, but it can be applicable only one input and one output. Okay. Suppose if we add one more input, suppose workers, let it be x1, and then labor is x2. So we have two inputs. Then the problem becomes complicated. You cannot find the ratio of two terms. One is workers by sales. The next one is labor by sales. So that becomes complicated. So that there's a DA is much useful to handle the multiple input and multiple output variable situation. The 5 bank branches. Here you see the multiple inputs case. You have x1, x2. How to find the efficiency? First one is x1 by y1 and x2 by y2. In some cases, the bank 2 may be efficient. In some cases, the bank 1 may be efficient. So the problem becomes very complex. Therefore, here the first method cannot be, the basic concept of efficiency cannot be used because it has multiple inputs. It is the case in case of multiple inputs. Suppose the outputs also multiple, then the situation becomes more complex. Supply chain operations, multiple inputs. You have 2, that is the bank, and this one is another example. Y1 is a profit, and x1 is a cost, and x2 is a. Hope that you can understand what you mean by inputs and outputs. And these are all the inputs and these are all the outputs. It differs from DMU to DMU. It all depends upon what decision making, what study you are going to consider. Okay, clothing shops. I have taken this example from one of the books, so all from USA. Okay. So multiple outputs, this is only example, don't bother about it. Multiple outputs, here you have 2 inputs and 2 outputs. X1 is dresses sold per week and accessories sold per week. And X1 number of employees and X2 management in weeks. In all these cases, you can apply DEA. Suppose if you want to find out which store, that means the store which is located at a particular place is efficient, you can run the program of DEA by keeping these inputs and outputs. You can find the efficiency of all the 5 locations, 5 or 6 locations. Okay. So now you see the input-oriented DEA model. Input-oriented DEA models are used to test if a DMU under evaluation can reduce its inputs while keeping the outputs at the current level. That means keeping their outputs at the current level, is it possible a particular DMU can reduce? If it can reduce its inputs and produce the same output, the particular DMU is said to be efficient. Minimum of theta and all that is given to you. Okay. So I give you the mathematical formulation of the example. You see the first two relates to the input and our output. We have 2 inputs and then the third one is output. Example. You see, we have 2 inputs. So now I am framing forming the mathematical formulation for this example. We have y1 all constant transaction 1000 and x1 teller hours and extra play hours. How to form, that means write the CCR program for this example. Here you see that 20 lambda 1 and lambda 2, lambda 3, lambda 4, lambda 5 are the weights attached to the 5 banks. Please remember, V1 and V1 are the weights attached to in the mathematical, that means the mathematical version, a mathematical formulation. That means multiplier version, your U1, U2 or V1, V2 are the weights attached to the inputs and outputs. When you apply that multiplier version, there you can find only the weights of the inputs and outputs. Here the lambda 1 and lambda 2, lambda 5 are the weights attached to the bank. For example, lambda 1 is a weight attached to the first bank and lambda 2 is a weight attached to the second bank. And then, so by applying the CCR model to this example, this is the mathematical formulation. So when you run the model by using a package or any program, you can make use of it. It obtains the value of lambda 1, lambda 2, lambda 3, etc. weights and the value of theta. And then output-oriented supply chain. Even in the supply chain model, you can give the same mathematical formulation for CCR model. Okay. So like this, you can write. So this is the third one, clothing shops. How to write the CCR model? That means input-oriented DEA model for. So I have given the example for input-oriented DEA model, mathematical formulation related to input-oriented DEA model for all the 3 examples. So similarly, the next one is output-oriented DEA models. The same concept you can make use of it if to write the program by using this model, and it obtains a value of neta. There, the theta is the scaling factor for the inputs, and here neta is the scaling factor for the outputs. Output-oriented models are used to test if a DMU under evaluation can increase, that means can augment its outputs while keeping the inputs at their current levels. So similarly, so for all the 3 examples, I have written the DEA program for output-oriented. Next. Okay. So the previous one is what we discussed is CCR model, and I told it is based on the CCR constant return to scale assumption. We cannot expect that situation always in practical life because the returns may not be constant. Sometimes it may be variables. So in such a case, what is the next model? So Banker and Charnes and Cooper in 1984, that means after 6 years, they developed the new model called Banker, Charnes, Cooper. It admits variable return to scale. Which one admits the variable return to scale? This convexity constraint. This convexity constraint, lambda I equal to 1. That admits, but when you look into the CCR model, the last constraint is not there. Last constraint, only this constraint, the introduction of this constraint differentiate this BCC model from CCR model. This last constraint, the other 2 constraints are same. Even the objective function is same. Only so the Banker and Charnes and Cooper just modified the CCR model by introducing this constraint called convexity constraint. That means the sum of the lambda j's, the weights to all the DMUs equal to 1. This convexity constraint admits the model variable return to scale. It provides variable return to scale. After that means after this model, BCC model, the DEA getting more popular, and it has been applied everywhere in almost all the fields because of its assumption. The CCR model admits only constant return CRS assumption, which is a rigid one. So that rigidity has been removed by introducing this constraint summation of lambda j equal to 1. That is called constant variable return to scale. So the basic difference of BCC and CCR is only this constraint. And what is the advantage means Suppose if you consider 10 decision-making units with some set of inputs and outputs, you first apply the CCR model. It reveals some of the units are efficient. Suppose let it be 5 units are efficient when you apply the CCR model. For the same set of data, when you apply Banker-Charles-Cooper model, it exhibits or reveals more number of units are efficient, more number of efficient units than the CCR. That is a major advantage. That happens because of this the convexity constraint summation of lambda j equal to 1, which admits variable returns to scale. So this is both the models we discussed to find the technical efficiency. One is CCR model and BCC model. Then the next one is cost efficiency. The same models can be used to find the cost efficiency, but the major difference is to calculate the cost efficiency, we need the price of inputs. The price of, if we know the price of inputs, then we can calculate cost efficiency. It is a ratio of cost efficiency is nothing but it is a ratio of minimum cost to the actual cost. As I told, allocative efficiency is cost efficiency divided by technical efficiency. Okay, and there are also revenue efficiency and profit efficiency. These are the efficiency. All these cost efficiency, revenue efficiency, and profit efficiency can be calculated by using the same model. That means so just to modify the models of CCR and BCC. Cost efficiency model. Here you see some of the product of the product of W. Here WIQ, XIQ is the nothing but a ith input of the Q DMU, and WIQ is the weight attached to the ith inputs of the Qth DMU. And some of the product of the cost, that means input prices and inputs will give the cost. So that can be minimized by using the minimized cost there to the ratio of minimized cost to the actual cost. That gives you the cost efficiency. So here also CCR developed the cost efficiency model. Cost efficiency model to see the same thing. To calculate the cost efficiency model to solve the following minimizers. So the Coily et al. Developed a software to solve this minimize WIQ. This is all similar to the input oriented or output oriented CCR model and BCC model. There we have only the actual inputs and outputs, and we find the weight of the inputs or outputs in multiplier version, or we have determined the weights of the decision making units in envelopment model. So here, in additionally, suppose if the price of the inputs are available, you can make use of this model. Suppose if you want to calculate the cost efficiency, this model can be used, but provided you should know the price of the inputs. Price of the inputs. Overall cost efficiency. The same thing, that is the minimum cost to the actual cost. And this is another model, revenue efficiency model. Okay, this is a model to calculate the revenue efficiency. So in cost efficiency model, we used input prices. To calculate the revenue efficiency, we need output prices. Suppose if you know only the output prices are available, you can calculate the revenue efficiency. If input prices are available, you can calculate cost efficiency. So overall, similarly, if you calculate the cost efficiency by using the actual cost, you can find the cost efficiency, overall cost efficiency. Similarly, overall revenue efficiency is nothing but the ratio of estimated revenue efficiency to the actual revenue, observed revenue to the actual revenue, and the profit efficiency model. Profit, the cost and revenue will give you then the actual profit of Q3 DMU is nothing but the revenue efficiency minus the cost efficiency will give you the profit. Actually, that is revenue minus cost will give you the profit. So that profit can be maximized by using this model. The same concept. So profit maximization in DA program and overall profit efficiency you can calculate by using this. So all these efficiency measures is bound between 0 and 1. If the efficiency value of theta, when you run the program, it obtains the value of theta and lambda. The lambda is greater than or equal to 0, but theta or phi, theta should be lies between 0 to 1, and whereas when the output oriented case, the phi should be greater than or equal to 1. If phi is equal to 1, the particular unit under evaluation is efficient, otherwise it is inefficient. So all these values bound between 0 and 1. Okay. So this is the some glossaries about DA I placed before you, and there are more things to learn. If anybody is interested in case of this efficiency measurement, you can go through the DEA zone. There is a DEA zone. Obtain the number of papers are there, and you can pursue your research. Anybody wants to do, but only thing is availability of data is very important. But in India, the getting data is slightly difficult. But nowadays it becomes very easy. So I placed all the concepts and some models before you. Now, please, it's a time for us to discuss. If anybody is interested, please come forward.
So, dear participants, do you have any queries or any feedback about the session? Kindly unmute your audio and ask the queries. So, anybody
It's very interesting area. May I know that the discipline of the participants, madam? Only mathematics or statistics or different disciplines?
So, different disciplines, sir.
Oh, very nice.
Yes, sir.
So if the time permits, I can talk more. That means I'll give some examples also, but it needs some more time. But in another FDP, I hope that I can do with the examples. And this is very easy. And you just leave my contact number to all the participants and mail ID, madam. If they have any queries, let them come forward for discussion. I'm ready to help them.
So, Nitya raised their hand.
Oh, yes, please.
Nitya, ma'am, do you have any do you want to share about any feedback? Nitya, ma'am. So, Nitya, ma'am, you raised your hand. So, do you have any queries? So, thank you, sir. Thank you for your valuable presentation, sir.
Okay, thank you very much for the opportunity given, madam. Convey my regards to the management and your principal and HOD of mathematics and my dear friend Dr. Manivannan. Thank you very much.
Thank you, sir.
Thank
Sir, now I request everyone to turn on your video for the photo session. Participants, please turn on your video. Thank you, participants. So, thank you very much, sir. Thank you, participants.
Now I request Ms. Renuga Devi, one of the coordinators of this FDP program, to propose a vote of thanks.
So, good afternoon all. I extend my sincere gratitude to our esteemed founder father, Dr. J.E. Arulraj, for his continuous support and vision that lead to the successful organization of the Faculty Development Program. A special thanks to Dr. V. Prakash, speaker of today's FTP, Principal Dr. Ambedkar Government Arts College, Chennai, for sharing valuable insights and expertise during the FTP, contributing significantly to our professional growth. Thank you, sir. I express my appreciation to Reverend Sister M. Baby, our beloved administrator, for her unwavering encouragement and support throughout the planning and education of the FTP. My heartfelt thanks to our respected principal, Dr. R. Rupan, for his commitment to fostering a culture of continuous learning and development among the faculty members. I acknowledge and appreciate the participants of faculty members from other colleges whose diverse perspectives and experiences enriched the discussions during the FTP. A special mention to the beloved head of the department, Mrs. Sujata, for their guidance and supports in ensuring the success of the FTP, showcasing their dedication to enhancing the academic excellence of our department. Last but not least, I express my gratitude to my dear faculty members for his active participations and enthusiasm throughout the FTP, making it enriching experience for everyone involved. I also extend my thanks to Visual Communication Department and our technical team. Together, your collective efforts have not only made this FTP a success, but also contributed to the continuous growth and development of our academic community. Thank you. So thank you, participants. Thank you all for your participation. We meet you all in tomorrow's session. Thank you all for your participation. So we request everyone to fill out the feedback form which has been posted in the chat box. So
Thank you, madam. I can leave now.
Thank
Thank
you,
you.
sir. Thank you so much, sir.
Thank you.
Oh, touch. So participants, kindly note. So the next session is on Monday, 4/3/2024. Thank you all.